So for this video, we're going to look at the data and also the bat files for how we got everything set up and running. So this is more background information. We're not going to actually work with the data, but I want to give you a little bit of an understanding. You can always skip this and move to just starting to analyze data, but I think you're going to be better off if you watch this video and really see how we put together those batch files to get data, the data running and in place, because it's just going to help you understand the process a lot better and then give you the ability to modify the process to suit your own needs. The first thing we can look at is the data. So in here you can see I've got a couple of different tables. A couple of them have these little globes on them. These are actually spatial data that I brought in. I decided I would give this to you because it's going to be a lot easier than you having to bring that in. So the cool thing about Sqlite is it has the ability to store geometries. If I right click here, I can say map preview, and you'll see there's a little map of the United States. And we're not going to zoom in or anything like that for now. We'll do that later. But this has information, again, for all the different states in the US, and we've got some codes for their names. I've got another table called the county table, and same idea. We can look at all the counties in the US. Here you go. So this is a little more involved. So this has all 3,000 plus counties in the US with their names, and we're going to be able to associate that with the coronavirus data. And I've created this other one, or brought in this other one called CBSA, which is all of the metropolitan areas in the United States. So you can see this shows our major metro areas. You can look at the New York Metro, the Philadelphia Metro, Los Angeles area. So we're going to be able to do some analysis later on, not just on individual counties, but on entire metropolitan areas themselves. I've also created another table, brought another table in called State Pop. And let's just say select star from State Pop, and we'll run that. So what this tells me is the individual states and their population estimates. This is important because we're going to eventually want to start asking questions like what percent of the population has been hospitalized over a certain time, or what percent of the population is positive for coronavirus. It's got a couple of other different things as well. It's got the region that it's part of. So there are 4 census regions, and it's also got the census division that it's part of. There are 9 census divisions. Here's an example of that from my textbook. You can see the 4 census regions, the Northeast, West, South, and Midwest, as well as the 9 different census divisions. So this will be fun. We're going to get to analyze the data based upon those regions and roll some of that information up. So those are tables that I gave you that came in, but there are a couple of other 2 other tables that actually came in, 3 other tables that we've actually processed. Actually 2 other tables. One is called COVID County, the other is called Daily. If you expand Daily, you can see there are a ton of columns in here. So let's just type select star from Daily, and because I don't want it to go for a while, I'm going to just say limit 100. So let's just look at what Daily has in it. You can see we have a date field, we have the state, the number of positive and negative, and then you can see all other kinds of data here. Currently hospitalized, and that's on that particular date, of course. There's other data as well. We'll scroll down here. Hospitalized increase. So this is the number of increases on that particular day. So this column here in 3, they had 41 people hospitalized. That's Arkansas on September 13th. And then, of course, we have the cumulative number for hospitalizations as well. So you can see we have hospitalizations, different kinds of tests, and so on. I got that data from the COVID tracking project, and they continually update this data. You can read a lot more about covidtracking.com data/API. And if we go down here to the metadata, the historic values for each state, you can scroll down, you can see the fields. So here's our date checked, death, and this will tell me what that is. These are total fatalities, confirmed or probable COVID-19 case diagnosis. Death increase, that's the new death, the daily increase in death calculated by the previous day's value. Death probable, the FIPS code, which again is a census code. We have the hospitalized currently as well as the hospitalized increase. You'll notice some of these are depreciated. I think when they started working with the data, they had these columns and realized, you know what, that's not a good name for it, so they added cumulative, hospitalized currently, hospitalized increase. Even things like who's in the ICU. So we could start asking questions like, how has the ICU increased in comparison to total hospitalization? And we know that ventilators were a big discussion a while ago. So how many are on ventilators? So you can see a number of different columns that are part of this. The other one is COVID county. So this is the data that comes from county. There's a lot of records in here. Let's just type this really quickly. Select count star from COVID county. And we'll just run that. So there's 666,000 records. Let's look at some of them. And again, this is going to be by date. Let's say limit 10. Just look at the first 10 records and see what we get. All right, so this tells me the county and the state, the cases, the deaths, and I added a column called new deaths. I'm going to show you how we do that in a little while. So I sure wish we had information on ICU and hospitalizations and all that, but this is what we get at the county level. If you can find a better set of data, please by all means do that. I got mine off of the New York Times GitHub site, and that's where again you can download all of their data. This is the best that I could find, and here's their live and historical data. If you do find another data set, leave a comment down below, let me know, and I will start bringing that data in and issuing some queries. Now we had to bring all that data in to get it into Sqlite. And to do that, we clicked on Get Data. That's a DOS or Windows batch file. And what that allows us to do is string together a number of commands. So the first thing we do is we run the get bat data, and then that calls the start states bat. So the getData.bat brings in the data from the web. Those data from the New York Times site as well as the COVID tracking project. Then it fires off a spatial light and imports a number of SQL scripts that begin to prepare the data. Those are in the start states.bat. And that runs a series of SQL. It gets rid of a lot of old junk that might be in there, and it creates a date field and populates it for some of our data because that date value is coming in as text. And then we create indexes to speed the data up. So let's step through these commands. And like I said, the first thing we do is we run getData.bat, and then we have to call startstates.bat. I wish we didn't have to do it, but it's just the way that Sqlite works. So the first thing we did is we run getData. This is running a DOS command, and I'm deleting any daily.csv. That's the data that came out that we got from the internet. I'm also deleting county.csv. That's the data that came from that New York Times site. Now I'm issuing a command for curl. Now curl is a library for transferring data with URLs. This is great. There's data on the internet. It's not like opening things up on your computer. And if you look at our directory, I've got a directory called curl, and in here is the curl executable. So I've provided that for you. So we're going to run that. And we're calling this website, this is the COVID tracking website that has daily.csv. That's all that data for the state. And I'm going to download it to a file called daily.csv. So now there'll be on my computer this file, this daily.csv. I'm running the curl script again, or command again, but this time I'm getting the New York Times data, and I'm calling it county.csv. So now I've got two files sitting in my directory from where I ran the batch file. The next thing I do is I run Sqlite 3, and that's under the Spatial Light directory. So if we look under Spatial Light, you'll see that we have all of our Spatial Light data here, as well as Sqlite 3. Now this is where I could issue I wish I could issue all the other cans, but I can't. I have to actually import into the Sqlite database, this COVID state.sqlite, the start states.bat. So you can see here I've got COVID state SQLite. It now has, it's about 42 megabytes in size. When you first downloaded this data, it had about 8 megabytes in size, and that's because I had all that data from the Sqlite inside of there. We come over here. So all of this CBSA, county, and state. So what's going to have to happen is this start states.bat has all that SQL that creates the tables and prepares things. It will run it. When it's completed, I get back into my Windows computer and I delete the daily and I delete the county because I don't want those things laying around. And then I start up the Sqlite GUI using the database COVID state.sqlite. Well, if we look at our start states batch file, the first thing we do is we set a mode equal to CSV. Then I delete the old daily file if it exists, because if we do this tomorrow, daily is still going to be in here. So I want to maybe get rid of that, and then because I'm going to bring in a new one. And then I say import daily. Remember, we just brought daily in and loaded daily.csv, so that's the newer data. I do the same thing for the county COVID as well. I get rid of the table. Actually, I've done that twice. I'll delete that record for you so you don't have to worry about that. And then I import the CSV file. This takes a little bit longer because there's about 3,200 records. Now, the next thing I'm doing is I'm altering the table daily, and I'm adding a new column called DT. All the way down at the end here. Now, why am I doing this? Unfortunately, SQLite does not allow me to change a field's data type. Most databases do. SQL Server, Oracle, Postgres. This doesn't. So what I have to do is play this little game where I add a table called DT, which is a date field. And then I'm going to update the table daily. This is an SQL update script. And I'm going to set the date to be equal to, and this gets a bit tricky what I'm doing here. I'm substituting strings, and I'm running from the first four, or the first column into the fourth one, and you can see 2020, 09, 13. So I'm going to, after that, I'm going to put in a little dash, so it'll be 2020 dash. Then I'm starting at column 5 for the date field, and I'm moving over 2 and I'm putting in another dash. So now it'll be 2020-09-13. And you can see it kind of looks like this here. So I'm setting date equal to that. And remember, I've set the field to be a date field. So this is now a true date, where this field is actually a text value. Now we're going to be working with a lot of different tables and joining them together. So I'm creating 3 indexes on the state table and the county table, where actually all on the county table because it's so large. We're getting the state index, the county index, and a county index for the date. So that way when I relate this table to the states table, or I search for things that are between 2 dates, it's going to be really, really fast. Now I'm deleting something called COVID County. It sounds a lot like County COVID, doesn't it? It's a different table. So what I'm going to do is get rid of that if it exists, because we're going to create a new table. Again, what would be really nice is if we could update the data for the new deaths for the counties automatically, but it doesn't. But again, SQLite is a little more restrictive. We could do this in Postgres or SQL Server or Oracle. So what I'm going to do is I'm going to have to turn this into another table, and I call it COVID County. I wish I didn't have to do that. I wish I could just add the field and do the updates, but it won't work in the batch file. It can work from the console here, but I don't want you to have to type this all the time. I want the batch file to write it. So we're going to then create this particular. So let's take a better look at what this query is doing. So this is basically the same select statement here that I'm going to look at, but I'm just wanting to look at the county data for my county, Wicomico County in Maryland. So if you look through here, you can see the number of cases, and then there's been no deaths in March, and we finally get a death March 28th, and that means we got a new death. Let's scroll down some more. Keep seeing all these ones. Well, here we go, from 1 to 3. That means there were 2 new deaths. So here's what my query is going to try and do. It's going to try and figure out if this is 3 deaths that were total of, and we had 1, that means we had 2 new deaths. Here's one where they made some corrections. Maybe the death wasn't from COVID, so we subtracted 1. So what we're doing is we're selecting all the data from COVID county, or excuse me, county COVID, and I'm subtracting the deaths from themselves. Now I'm saying from COVID, county COVID, and then county COVID as D2. I'm pretending there's another table called D2. So that's a really cool thing you can do in SQL. And I'm doing it where the FIPS value for this data, which is the unique state and county code, is equal to the FIPS data for the sort of the pretend table that I've created, the virtual table. Now, I'm subtracting the deaths from the other table where, and this is a cool other function, Julian day. This calculates the Julian day between the COVID date that we have here and the date from D2, which is the same dates, but I'm saying where it is equal to 1. So where this date subtracting any other date is equal to 1. So the 18th minus the 15th is 3. That's 2. The 18th minus the 17th, that's 1. And when I subtract the 2 together, in this case, 1 minus 1 is 0, so I get 0 days. But 3 minus 1 is 2. So that's what is being calculated as new deaths over here. So it's just a tricky little way to update each of the fields. So now I know how many new deaths came within that period of time. So we can start to look at how many deaths have occurred between 2 different dates. It's harder to do when you're looking at a running total. Last couple of statements that we'll look at here were just for county COVID. I'm adding an ID column because we're going to use that later. So we have a unique value, and that's equal to the row ID. And then I get rid of county COVID. I don't need that any longer. And then this command we use is called vacuum. What this does, it just cleans up a lot of the junk that's inside of the database so it doesn't get so large. And then I exit. Now when I exit, I've now gotten past this part, this bat file, so I'm back into get data. And then I get rid of the daily and the county, and then I fire up the GUI and open up our database. And that's what we have here. Well, if you like that, what you can do is go to my website, gisadvisor.com and artlembo.com under books, and I've got a number of different books, the statistics, but also I have a series of books. The How Do I Do That series that shows how to do a lot of processing, SQL and GIS processing in things like Postgres and SQL Server and Manifold GIS, but also Spatialite. So if you click on how do I do that in Spatialite, you'll go to a web page that has a free book you can download as a PDF that will show you all of the types of steps we use to perform classic SQL and GIS tasks using SQLite. And I'll scroll down here really quickly, and you can see some of the ways in which we alter tables, how we sort data. So you may want to get this anyway, because we're going to use and exploit a lot of these kinds of commands for the rest of this video. So we're going to move on now to looking at some of the basic queries for searching through the statewide data in coronavirus. If you like this data or like this video, please give it a like and also subscribe to the channel so that way as more content comes out, you'll be notified, because we're going to continue to walk through this process.